Yes, you can hear me anyway, yeah. So I'm Tomás, I'm the CEO of Hereworks, and we're based in Ashbourne in County Meath, and we're actually a division of McKeown Group. So McKeown Group is a main contractor, main contractor going back to 1950. So we've been in the construction industry for a very long time. It's a third generation family business, actually. We're a Well, what are we? I'll say master systems integrator for the moment. I would say we're at least one of the leading MSIs in the UK and Ireland, and we work a lot with. We mainly work with Richard talking here about, and funny, we're working on a project together where Richard is the landlord. Connor is the digital building consultant, and we're the smart building integrator. And but we generally work more so with the end users. So Richard kind of touched on the differences between what the landlord might do, getting the building smart ready, and then what the occupier might do. So just bear that in mind. And we mainly work with in commercial offices. So the likes of Google, the likes of MasterCard, Lazard, consultants, Dublin City University. We work again a lot of large corporates, banks, that kind of thing. A lot of consultant firms, accountancy firms. So if we move on, MSI. So MSI, as Connor pointed out, is a master systems integrator. Is that what we are? Yes, but it's only one of the services we offer, and I'll explain this as we go. So are we a smart building contractor then? Or a digital building contractor, or a term I was using for a while was a management contractor for smart buildings. So think of it this way: if Richard is the developer and the client, Connor is the architect, and we're the builder. We're the building contractor, and ultimately the managed services contractor for your smart building, for the smart element of your building. So you remember Connor's three kind of processes there. We'd come in on the second and third layer. Let's run with the term smart building contractor just for the purpose of this talk. And I suppose much like any contractor, any building contractor or any main contractor, we take full responsibility and the risk for the smart building delivery. So once it gets past design, and we take that concept from design to reality. So we'll decide on the methodology to use. So how are we going to actually install this, deliver it, and what's the final choice of ontology, technologies, equipment, even subsystem providers. So we don't do everything ourselves. We rely on specialists, whether that be for lighting control systems or for various different systems, BMS, etc., that may go into the building. There's a couple of key concepts that I suppose Hereworks would, I won't say insist on, but would rather how we operate. And I have them up on that is the wrong, that's the, hold on, let's see if I can fix this. To mind the bit in the top, right? That came from somewhere else. But if we take these bit, we must be agnostic. And I think this is a really key. You saw up on Connor's slide, I think it was in the car screenshots, which is Claire's Trinit platform. I think you've seen a couple of screenshots from Smart Spaces, which is an occupant kind of tenant experience app. I didn't see anything from Hereworks Happy, but I'll talk to Connor about that afterwards. But that's the point. A smart building contractor or MSI must be agnostic. So we're not pushing any particular technologies, and that's really, really important. So we start with the foundations, like any building, we'll start with the foundations first. So that's the ontology, the naming scheme, the independent data layer, horizontal architecture. I'm going to explain these terms in a minute, so don't worry. But we don't lead with any software or apps. We do have our own platform. It's called Hereworks Happy, but we never lead with it. We will sell it to other MSIs. We'll sell it to clients, but we would never, if we're acting as a smart building contractor, we'll never lead with it. It might be part of the solution. It's a very human-centric type app, but we'd never lead with that. We need to hold the top level responsibility for the data. So again, Connor touched on all the different systems. Once we're on a project, we would hold the top level responsibility for getting all the data from that system. So that means that we need to work very closely with those subsystem providers, and they need to conform to the ontologies, the naming schemes, and everything that we develop. And then ultimately, we're responsible for that data. We're generally contracted to the client, so direct to the client. And that's important. We generally come in, I suppose, if we were to go with the REBA stages from the UK, we generally come in at stage 3. So just beyond concept design, we work, digital building consultant comes first. They would then tender for an MSI, and we generally come in before the main contractor. And the reason behind that is, certainly at the moment, there's a ball of work required to deliver a smart building. I know Richard mentioned it's getting simpler. It is definitely getting easier, but certainly the systems can all talk to one another, but it's still a lot of work of actually getting those systems to conform. And therefore, all the subsystem providers have to buy into that. Now, you're dealing with massive companies like, I mentioned names like Mercury, Jones, all these guys, and other companies that are around for years. They've been delivering building for years. They can do this stuff with their eyes shut. And then suddenly you're asking them, well, all the data now you have to work with Hereworks, and you have to conform to their methodologies. And there's a big people skill bit in that, and actually bringing them on that journey. So acting on behalf of the client rather than the main contractor is important. Now, often we'll get novated to the main contractor once they're appointed, but even actually the choice of main contractor, sometimes we sit in on the interviews there as well. The final thing is really a Hereworks one: focus on the human, and we'll get everything else right. And I see that is a shift that's coming only really lately in the market. But basically, we'd say if we focus on the human, how they behave. Well, first of all, we look after well-being. All the research would show that if you focus on well-being, you'll increase productivity. If you do the opposite, if you focus on productivity, you'll actually reduce well-being. If we focus on human habits, we can increase space utilization, reduce waste, and we can reduce waste associated with facility management. So basically, focus on the human, learn from what the human's doing in the building, and we'll get everything else right. I'll skip over this one because I thought I had a much longer slot. So, so why the confusion in terms between MSI and, I suppose, smart building contractor? So I'm going to just talk about this idea of full stack smart buildings. So what do I mean by full stack? Well, it means we deliver everything across those four pillars there. And I'll talk you through these in more detail. So traditionally, the MSI role, and actually I was in the States there a couple of weeks ago at a conference, and MSI in the States, so Master Systems Integrator, works in that foundation layer. So they're the ones that connect all, like, think of a controls company, a BMS controls company. So an MSI to them would be a BMS controls company that is upskilled to send the data to the cloud. So when we talk about full stack, we're talking about, well, actually, let's add to the BMS system, deliver some sensors and IoT that are required in addition to what's already there to deliver some of Connor's use cases. We'll supply and integrate the software layers, and then actually we'll move on to post-building occupation and manage services. So that's what we talk about when we talk about full stack. Connor talked about siloed systems. So if you see down the bottom, they would be your traditional siloed systems, the way they used to work. Your lifts, your fire alarm system, your BMS, they worked perfectly well. They worked perfectly well on their own, but they never spoke to one another. So they couldn't learn from one another and couldn't give insights collectively. They all spoke a different language. And indeed, you could often double up on technology. So how many times have you gone into a meeting room and you've seen 3 PIR sensors, one for the lights, one for the BMS, and one for the AV system? So getting away from those siloed systems is what the horizontal architecture is all about. And the first building block of an intelligent building is those foundations, obviously. And the foundations are essentially the data layer. of the intelligent building. So that bit in the green there in the middle is the data layer, and that's what I mean when I talk about foundations. Every single building service, starting with the BMS as a minimum, should connect to that data layer. And that means conforming to a structure which can evolve and develop over time. And you'll note that the word ontology there. And that's what I mean by ontology. That's a structure. It creates a common understanding and language between how different components interact and share information. And there's lots of them out there. We use Google Digital Buildings Ontology a lot. There's Brick, there's Haystack. You can even create your own. Part of the data layer as well is the naming scheme. Because remember, from a software systems point of view, Room 101 is not the same as RM 101 or R 101. So you imagine when we work in siloed systems and you have 7 different commissioning engineers and they all use their own naming scheme, then it's impossible to join those at a later date without a lot of work anyway. And that's data layer really is where the smart building contractor is there to protect. So there shouldn't be multiple data layers, and there certainly shouldn't be data layers created for a means to an end. So that's that idea of leading with a particular platform. You got to see what actually, you got to understand the wanting requirements first, which Conor will really gets into at the design phase, and then design your systems around that. I've lost my train of thought there, but what was it? Where was it going? Yeah, the interesting thing there is what you think the building might be used for now, and again, certainly if the landlord knows that, you know, okay, you might have 10, 20-year leases, but actually how even the occupier envisages the use of the building might change over the next 5 years. So actually, if you did nothing else with your smart building, just build that data layer, build the foundations. Don't add the fancy IoT and all the different systems and apps on top of it. If you're, you know, there is a cost to these things. So actually build the data layer, connect the essential systems, your BMS, your lighting, etc. Wait for a year, see how the building is being used, and then we can add additional sensors. So if you're budget constrained, that's one option, but don't start with an end system in mind. So then the next bit is sensors and IoT. Kind of already touched on that. Basically complementing the base building sensors that might be there from the BMS to deliver use cases, generally around well-being and comfort and space utilization. We connect systems that aren't smart ready or IoT ready by using these kind of gateways or integrators like the JACE 9000 here. That's a Tritium device, the blue and black one there. So that will take sensors that connect via BACnet or Modbus and actually convert them to conform to the normalized structure of the ontology, and then send it maybe up to cloud systems using what's become now the standard really, which is an IP-based protocol, MQTT, for actually sending information to the cloud. Ideally, if your hardware is MQTT ready and conforms, you can actually send the data straight to the cloud rather than going through integrators. So I suppose the smart building contractor needs to have that broad range of experience with different BMS systems, with different protocols, and I suppose connecting all those systems together. It is getting more standardized, and I'd say, you know, in the next 3 to 5 years, it will get a lot easier to integrate systems. There will be proper ecosystems developing, and I was talking to Paul O'Connor there. There's good collaboration in the industry at the moment. People are sharing knowledge for the greater good, I suppose, of the industry. So we mentioned a single pane of glass. So this is basically a layer that would sit on top of all the, you've seen it there in the horizontal architecture at the top. So basically, it's a unified interface that integrates and displays all building systems and data in one centralized, easily accessible platform, simplifying monitoring, insights, and control for building managers. This screenshot here is our own example. It's Hereworks Happy, which, as you can guess, is human-centric. And it surfaces insights from all the building systems to help improve the human experience. We kind of get bogged down in, as engineers and facility managers, get bogged down in dashboards, graphs, and Excel sheets. But actually, surfacing actionable insights to get away from all the noise, because there's so much data there. It's really hard to for a human certainly to understand. So there's great developments in machine learning, etc., to help surface really actionable insights that facilities teams can take on board. And then there's the final stack in full stack, or the top of the stack, which is managed services. Smart buildings are complex, and there is a lack of, I have a slide on skills later on, but there is a lack of internal expertise in a lot of companies to maximize success really from these technologies. As Richard mentioned, it's all well and good collecting all this data, but what are you actually going to do with it? Typically, a support and maintenance contract includes physical device maintenance. So that might be recalibration of sensors. We're all probably aware of the well building standard and those kind of standards, and they require a certain level of recalibration on an annual or biannual basis. Then there'd be ongoing data validation and accuracy, because again, if the data is not accurate, it's not worth anything. Security is one of our big clients is Google. That is their main driver for smart buildings, is security. They are scared to death of what they're putting into buildings. And you can't blame them. I mean, we've seen some of the hardware there. They have microphones in them. They've cameras in them. Where's that data going? So actually continuously looking at firmware and upgrading things and allowing for new threats. That's part of our managed services. Licensing, there's typically thousands of devices in a large building, and they may or may not have license requirements, so actually managing those licenses. Security certificate management on devices. But unlike, I suppose, a lot of other specialisms, the smart building is never finished. And really the true success comes after completion, because that's when you start to see the data flowing, and that's when you start to see the insights that you weren't really expecting. Because people often say, well, what do we expect from these insights? Well, it's the stuff you're not expecting that is of interest, and that will only come after the building goes live. So what we do, well, a lot of our maintenance contracts, certainly in the UK. So in the UK is really demanding this full stack from us at the moment, rather than just the MSI role. And what we do with our managed services over there is we provide what we call an SME, or a subject matter expert. And they will work maybe up to 1 day a week with the client, actually analyzing the data that's coming from the building and helping them understand the insights and actually find the teams that are that can help actually take action from the data as well. I suppose, given this talk is about operations, as I go through I have a few examples here, and I'll go through them quickly. Just have a think about who actually, in a building, from your own experience, might be responsible for taking action on these insights, whether it be facility management or workplace or beyond. Because it's not just, and I think, for a long time, we've always talked about smart buildings in terms of building systems and plant and energy, but actually bringing the human right into the center of the data. We enable our clients to manage efficiently and effectively the building occupant experience and the real estate. And touch very quickly on Solve. This is a feature of our own platform. It's called Hereworks Solve, and it's a major component of Happy. But effectively, we use these Solve tags, and we place them on various assets. They're location-aware tags, And we place them in various assets around the building. But what it effectively does is it enables humans as a sensor. So very, very quickly you can tap one of them. Anyone can do it from any device. There's no login required. And you can report, you can request help, or you can report you're too hot, you're too cold, or you could report any issue on the building. It takes about 5 seconds to do it. But you then have this human feedback, this human as a sensor in the same data lake, conforming to the same ontology as the building system. So you've suddenly enriched this, and you can see, well, this happened with our building systems, and this is how the humans reacted. So let's have a look at some real insights, and I'm going to fly through these quickly, but we might have a minute at the end if we're allowed to discuss more. Impaired cognitive ability. So this was a room, massive CO2 levels. And basically what was showing was we had indoor air quality sensors here, we had space occupancy sensors here, and we seen there was 26 people in this room day after day. The CO2 levels were staying up there at nearly 2,500 ppm at times. Now that is, anyone who's familiar with CO2 levels, you want to be below about 900. You'd be falling asleep. If you think my talk is bad, if you had to sit through it at 2,500 ppm, you would be asleep. You would have headaches. So anyway, just had a think about that. In that case, the BMS could not keep up, could not increase air changes. It wasn't possible. But what we did know was the room was designed for 15 people. There was 26 people in it day after day, and there was plenty of other bigger rooms available. Energy saving. Here's a classic one. Again, every morning. So you see the peaks every morning. The room was being, and there's several rooms, I believe, in the same building, peaking to 27 degrees every morning, and then somewhere between 8:30 and 9:30, it would go back down to more comfortable 21 degrees. What was happening there was BMS was set incorrectly to heat the room to 27 degrees. So the BMS did it. Didn't see anything wrong with it. Humans would come in, turn the temperature down, and they did that every single morning. So obviously energy wasted, discomfort for the employees, but also just the head-wrecking nature of having to come in and do this every single morning and see nothing done about it. That came back to a BMS system that was 3 years old, that really they were still having an issue with commissioning. So smart systems overlaid on top of your traditional BMS can really help with commissioning and highlight these problems, because the BMS just says, yeah, calling for 27 degrees and getting 27 degrees. Unhealthy conditions. So TVOX, total volatile organic compounds. This was an IT room, if I recall. And we were getting these massive spikes day after day, week after. Laptops, thought it was that spraying, so we did a spray test, but it didn't come up anywhere near the levels that the others was. It would disappear for 2 weeks, then it might come back, and was never there during the holidays. It was vaping. So again, our SME worked with the client. Here's another one, just combining, and I'll flick through this very quickly. This is water usage versus occupancy. Generally, there's a lovely correlation between, the people in the building use water. Nobody in the building don't use water. Typical water occupancy comparison. Christmas comes, you'd imagine, maybe they had a big party here, a lot of water, and then Christmas came. But actually, no, that's not what happened. There was the anomaly detection fired in the system and said, we're using too much water. In the same platform, we started to get reports from the humans that there was something leaking in the gents' bathroom. Facility manager Arthur went down, turned off the penny valve, usage went to 0. Everybody went on holidays. Came back in January, anomaly detection fired again. Someone had actually gone back and turned it on. It wasn't the facility manager. Anyway, this time Arthur went down with the plumber and fixed it. But I just think it's a good example of combining that human feedback with building data, because Suppose if we only had the meter data, would we even have noticed it? Probably not, because who sits looking at meter data? Anomaly detection, yes. Okay, now we know there's an issue, but how do we find it? Combine the human feedback, and suddenly we have obviously saved resources and time for everybody involved. Other recurring trends, I'll not dwell on these, but again, just recurring trends that are coming in to the same platform, real things that annoy people. Sit down at a hot desk and you're missing a cable and you can't work. Recurring all the time. And what was happening was IT were just going replacing the cables, but they weren't getting to the root of the problem. Am I under pressure? Am I? Yeah. Fault detection diagnostic. Actually, very quickly, how many people know what a fault detection diagnostic system is? Well, nearly everyone, but you would be surprised how many people I talk to in the M&E industry that don't know about this technology. It's very mature now. It's very cost effective to put in. It's basically a supervisor that sits on top of your BMS system, and it looks for those kind of problems that we looked at earlier, things that, simultaneous heating and cooling, all that kind of stuff. And it will save between 5 and 30% depending on the building. I better keep going here, but just human experience for us is the key. And who do we never see at the smart building table? We're generally contracted by real estate, facilities, or the construction team. We never see human resources at the table. And really, to me, that's the most valuable ROI in a building. So I think we need to reimagine, and that's why I just asked just there, like who, we're here to talk about operations. Who is responsible for those insights that we've seen there, for fixing those issues? And who has enough clout to do that? Because the facilities team, they just have a contract. And the contract there's very little margin in it. And if they're going to do there's no room for proactivity or changing things and that, changing human experience. I think human resources need to be at the smart building table. So we've come up with this kind of cross-functional idea of Swift HR. That would be a new reimagined way of how we manage facilities. We all had a little slide on what's next, so I'm going to skip over this one. And just to mention, these are the skills I think that we need to build upon in smart buildings. We've got very, very specialists in our, I suppose, the engineers and the specialists that are coming up. There's very little that have a broad range of skills like that kind of Swift HR slide there. And to me, that's what we need to do, is build out those holistic skill sets. You think of the old facility manager, we all know them and they know every bit of the building inside out and they know everyone in the building. That's a dying breed. And so we need to combine technology with these type of skills. And I just threw up a couple of resources there. Obviously, CitA themselves, Nexus Labs is an American organization, and they do a lot of foundation training in smart buildings. CIBSE, our Stephen Weir, who's our MSI director, is the current chair of CIBSE Ireland. They have an intelligent buildings group, so they'll be publishing a lot of papers in the near future. And the Digital Buildings Council, again, a new group set up in the last year. And again, watch that space. But good resource. Digital Building, DBC, it's UK and Ireland. So we're founding members of DBC, and there's about to be a big announcement around membership and actually all the programs they're about to undertake. So that's me. Hopefully I wasn't too far over time. Thank you. Thanks a lot.